So in 5.3, we're going to cover 3 different types of identities. The last ones that we're going to hit are power reducing identities. This section is pretty much 5.4, so we'll come back to that. And then we have double angle identities, and we've got half angle identities. And one of the things you need to notice about the half angle identities is that they can either be positive or negative. So for instance, if you're looking at some angle that was in quadrant 2 and you took half of it, well then you would be in quadrant 1, so you would have a positive answer. Okay, so, but we'll hit that when we get to it. Again, we're just going to start plodding through and see what we can get. We have, how many? We have, hey, there's not many. About 14. Okay, so I'll try and get a good smattering of both, or of all 3 types. So first of all, we have use the figure to find the exact value of the following trig function. So I have the sine of 2 theta, which means whatever my angle measure is, I have doubled it. So what I want to do is rewrite this thing and say, first of all, notice that I'm finding the sine of double whatever this angle is, but the triangle that I'm given is just the regular multiple of the angle, or just once, okay? So to give you an example, which this is not it, if this was 30, then this would be 60, because I'm doubling it, okay? All right, so first of all, waddle on over here, and again, in this case, in Pearson, we're going to use thetas for the most part, or x's, but what I typed up is using alphas and betas. So I do know that I've got the sine of some double angle, and I know that it is equivalent to double, or to sine alpha cosine alpha. So notice that this is double of whatever I'm looking for, but I'm going to rewrite it in terms of a single angle measure. So this can be rewritten as sine of 2 alpha is the exact same thing as 2 sine of 1 alpha cosine of 1 alpha. Well, do I know what the sine of 1 alpha or 1 theta is? I do, because it is opposite over hypotenuse. So that becomes 2 times 4/5, and then the cosine of alpha, or theta, is adjacent over hypotenuse, which is 3/5. And now all I have to do is simplify this. So my denominator is going to be 25, and then 2 times 4 is 8, and that gives me 24. So this is 24 out of 25. So what does that mean? That means if I doubled this angle, okay, a simplified ratio for sine would be 24 over 25. And you use this triangle to get there. So again, let's try that again. I've got the cosine of 2 alpha. So here's cosine 2 alpha, and now you got 3 options. Any one of these 3 is fine to use. You're going to find out in section 5.5 that there are times where we're going to prefer one over the other, but for right now, we don't care. So just for ease, I'm going to say the cosine of 2 alpha is going to be cosine squared minus sine squared. This is not a Pythagorean identity. Okay, this would have to be addition, and it would equal 1. So we're not doing that, so just be careful that you don't fall into that trap. So I've got the cosine of 2 alpha. Again, I'm told that here's my alpha. I know that this is 3, 4, and by Pythagorean theorem, I can figure out that this is 5. Or I can remember it's a 3, 4, 5 triangle, or I can look right here and it's already done. All right, so I've got the cosine of 2 alpha, and I said I'm just going to use this top one just for fun. I don't care, you'll still get the same answer regardless of what you use. So I'm going to do cosine squared alpha. This pen is horrible. Cosine squared alpha minus sine squared alpha. Well, what is the cosine of this angle? It is 3/5, and I need to square it, okay? Minus, what is the sine of this angle? It is 4/5, and I need to square it. So this gives me 9/25 minus 16/25 gives me what? 9 minus 16 is going to be a negative 7/25. Okay, so what does that mean? Your cosine, if I double this angle, is negative. Well, if you'll notice, all of my stuff is positive. If I double the angle, that's going to take me into quadrant 2, and cosine is negative in quadrant 2. So it kind of sort of works itself out, which is kind of the point. And there we go. All right, so we're going to work backwards. So this time it says rewrite it as a double angle. So I'm not sending you adrift with no hints, okay? I've got a 2 sine alpha cosine alpha. So I notice that my angle measures match. So I need to rewrite this as a double angle. So come over here. Well, there's my 2 sine alpha you can't see. 2 sine alpha cosine alpha. Okay? So if I rewrite this, noting that this is an alpha and this is an alpha, that means if I want to come back over to the left side, I need to double whatever my alpha is. So this is going to be rewritten as the sine of 2 alpha. Well, what's my alpha? It's 157.5. So that becomes the sine of 2 times 157.5. This is a horrible pen. All right, so I get, I don't know what that is. Hang on. 2 times 157.5 is 315. So this becomes 315. And now do I happen to know what the sine of 315 is? I do. I am in quadrant 4, and it is going to be 7 pi over 4. No, I'm sorry. It's going to be the same thing as 7 pi over 4. So the sine of 7 pi over 4, sorry, I'm used to working in radians, is going to be negative root 2 over 2. Okay? So hopefully that's starting to make sense. You're just kind of sort of applying these identities and going through. So again, it says a double angle. I'm looking at cosine squared of a value minus sine squared of a value. So I would like to know what that is. So if I look at cosine squared, that's not even close to what I was grabbing. Cosine squared minus sine squared. So look over here. Well, here's a cosine squared minus a sine squared. Your angles match. So revert back to this side. Whatever that angle measure is, double it. And that's going to be your answer. So this is going to turn into a cosine of double 360 or double 180, which is 360. So the cosine of 360, which is the same thing as a cosine of 0, is 1. Now technically you wouldn't even had to do it on this one because the cosine of 180 is negative 1. So that would have been negative 1 squared. Minus the sine of 180 is 0 squared. So negative 1 times negative 1 is 1. Okay. So now you've got some tangent. So I've got 2 tangent of 7 pi over 12. So 2 tangent of 7 pi over 12 minus 1 minus that tangent squared. So I want to rewrite it. I do know it's going to be in terms of tangent. And so I know that I'm just going to take my angle measure, and to revert back to the left, I just need to double it. So doubling 7 pi over 12 is going to give me 14 pi over 12. Okay. So this becomes the tangent of 14 pi's over 12. Always remember to double just your numerator. If you double the numerator and denominator, then you've multiplied by 2 over 2, which is 1. You haven't changed anything. If I reduce that, that is 7 pi over 6. Okay, so what is the tangent of 7 pi over 6? He's going to be in quadrant 3, which is going to be positive, and he will be root 3 over 3. Okay, so the tangent of 7 pi over 6 is root 3 over 3. Let's find some more exciting ones. So you want to verify the identity. I've got a negative sine of 2 theta. So knowing that, which one is an obvious thing that I can use? Well, this isn't going to work and this isn't going to work because I'm carrying along a negative sign. And then I've got to use 2 sine alpha cosine alpha. So this is going to become negative 2 cosine alpha sine alpha, 2 cosine alpha sine alpha. And now you have to either go this way to make that decision or go this way to make that decision. So basically all you're trying to do is figure out how to morph from here to here. So if you'll notice, that's going to be a Pythagorean identity, but which one is it? So you'll need to decide if it's cosecant squared going to here or if it's secant squared going to here using a Pythagorean identity, but narrow it down first. So to transform the left side into the right side, hang on, I don't know. All right, so I've got a angle measure, a double angle. So I've got a 2, hang on, this stupid pen is ridiculous. 2 sine squared x, and then I'm going to, instead of a cosine 2x, I'm going to grab one of these. Well, which one makes it friendlier if I'm trying to get this thing equal to 1? Okay, So if I can somehow incorporate, change this into something that has sine squareds in it, okay? So what if I say 1 minus 2 sine squared alpha? So instead of this one, I will say plus, instead of a cosine 2x, I'll say 1 minus 2 sine squared alpha. Well, 2 of these minus 2 of these is going to give you 1. So what did we do? We converted this one into the 1 minus 2 sine squared. Okay? So use power reducing formulas. So I'm going to show you one of these. So I've got 72 times the sine squared of x times the cosine squared of x. And I want to simply rewrite this. It's going to be ugly. I want to rewrite this as long as every trig function does not have a power other than 1. That is my mission. Okay, so I'm going to write it down here, even though it skips this one. So I have 72. And instead of sine squared, I'm going to write that as a 1 minus cosine 2 alpha over 2. So 1 minus cosine 2x over 2. And then what is cosine squared? Cosine is 1 plus cosine 2 alpha over 2. So 1 plus cosine 2 alpha over 2. So what you can do is both of these have a 2. And remember, multiplication is you multiply straight across. So 2 times 2 is 4. So 72 divided by 4 is going to be 18. So that gives me an 18. 1 minus cosine 2x times 1 plus cosine 2x. So do both trig functions have a power of 1? Yes, they do, which means you don't have to do anything else. Okay, you're done. So remember, I've got it simplified or set up as unsimplified answers is correct. All right, so here's a half angle formula. That means I took half of something and got this answer. So if I double this, that means I have cosine of double that. That gives me a 45 over a 2. Okay, so does that make sense? If this is a half angle, then double it to figure out what it was and just use it in its unsimplified form. So now come up to your, hang on, I've lost control, your half angle identities. Okay, so first of all, I'm taking half of 45 degrees. That tells you you're in quadrant 1, which means I'm going to use a positive answer. So this is going to be positive 1 plus cosine alpha over 2. So I have positive 1 plus cosine, what is my alpha? Because it's alpha over 2. So this is 45 over 2. Well, I happen to know what the cosine of 45 is. The cosine of 45 is root 2 over 2. So I've got 1 plus root 2 over 2 over 2. And that's so ugly. That is so ugly, but that is the right answer. All right, so I'm going to see if we can skip some of these things. Use the adjacent figure. So if I know what theta is, I want to know what the half angle for it is. Okay, and if you'll notice, everything's positive. So if you chop that angle in half, you're still going to be in quadrant 1. Okay, so I want to know what this is. Use this value. So you're going to take 1 minus the cosine of alpha, which is 1 minus 24 over 25 over 2. Okay, same thing for tangent. You can draw a picture, and then you can use your appropriate half angle identity to figure your way through there. And then this one, again, just figure out what you got. This is going to be negative sine because you flipped it. I'm sorry, good heavens, negative cosine because you flipped it. So you just got to figure out how to get from here to whatever your simplified answer is. Okay, so I know this is really rough, and I wish we hadn't missed chapter 5, but there you go. And the last ones you can watch videos. Okay, so that is 5.3. So I'm going to try and get 5.4 uploaded tonight, and then I'll hit 5.5 tomorrow so you can get on top of stuff.